Well, gentlemen,
Welcome to Groundwater.
Today you guys have the trifecta of teachers. All three of us, best of the brains combined together for this video.
all right, so we're going to dig into groundwater here and start out with some really basic information for you. So for the first video, we're going to be talking about porosity and permeability. And you can see the learning targets here, so please pause your video and take a look at them so you know what you're looking for in the video. And remember, if you're not using video notes to do this and take your notes, you should be.
All right, so we're taking a look at this unique diagram, and we want to just kind of put into perspective just all of groundwater and where it fits into all of the water on Earth. So we have this unique kind of set of columns here, and all the way on the left we can see all the water that exists on Earth, and we can see that about 96.5% of all the water is ocean or saline water that we had talked about in the last unit, the marine environment. And we only have that really, really small portion up at the top, all right, that is only about 3.5% that ends up being all the fresh water on Earth.
And if you take a look at that fresh water, you can break that down into two main parts. Most of it, about 68%, is frozen. It's glaciers, ice caps, and actually 30% of that 2.5% is beneath our feet. So it's water underground. And you guys can see a small fraction of a fraction is actually water that we're used to seeing every day. So lakes and rivers, it's an amazingly small amount of water that's present on the face of the earth.
So just because we're lucky enough here in Chicago to be able to get our water from Lake Michigan, I think it's a deception that there's a lot of water, when in reality there are wars being fought over water.
Sure.
There are people who are dying of dehydration because they don't have access to clean water, and it's because of what you're seeing here on this graph. Groundwater is only a very small portion of the water that's available, and that's what we need to drink and to irrigate crops and to feed livestock with. So if we're going to take a look at just the groundwater supply, we need to understand how that water is stored underground. And it's not stored as a river. There aren't rivers flowing underground under our feet, right?
Yeah.
It's stored within the open spaces or the pores in rocks, spaces in rocks, because we think of rock as being solid, and it's stored within the spaces between sediment grains in unconsolidated sediment.
So it's kind of like the rocks act like a sponge almost, and the rocks can soak in water, and those are the little pore spaces in the rock that hold all that water present.
Exactly. And then when we try to get that water out of the ground, we drill wells into those rocks that contain the water.
And we need to start to think about how slowly water would actually flow through those pore spaces, and how those pore spaces are connected up to each other, and how that's going to control the flow rate. So in lab, we're going to look at how much pore space there is in sediment. We're not going to look at it in rock, but in sediment itself, and then how the water flows through those, the rates.
And we calculate porosity in terms of a percentage of space. So how much of a volume, what percentage of that is open space or pore space?
So let's take a look at the next slide, because I think we've got some examples on that slide of how much porosity there is, how much open space there is in different types of sediments. So here you can see the range from a low of about 10% in glacial till. Well, glacial till is very poorly sorted, meaning that you've got big grains surrounded by smaller and smaller and smaller grains. So you wouldn't expect there to be a lot of open space because the smaller grains are going to fill that in. So the lowest porosity is about 10 to 20% for glacier till. And then what are the higher ones?
Surprisingly, one of the real high ones is clay. You think of clay like water doesn't really move through it, but clay really acts as a sponge. And it can actually, it's got all these little nooks and crannies, and clay does a really good job soaking in water and holding on to it really well. So it can actually have up to 80% of the space that it takes up is just empty space.
And then on the lower end, we have something like gravel, which only has about 25 to 40% of its volume space being pore space. And that's kind of deceiving, that like the bigger grains and the spaces between those actually don't add up to a whole lot compared to the smaller grains. All right.
So realize that there is this range of porosity, and we'll be checking those out in lab. Okay, good. What about the ability of the water to flow in those different substances then? So we need to talk about permeability. How easy is it for water to travel through the material, whether the material is rock or it's a unconsolidated sediment. So what do we know about that?
Well, I like to think about it as, like, let's say I had a bucket of each of different sediment sizes. So if I had a bucket of gravel, a bucket of sand, and a bucket of clay, and I dumped water into the bucket, how long would it take for the water to flow through? So gravel, the water would flow through the spaces really well because those pore spaces are really well connected. The water would just go right down.
Okay.
Sand, it's not as easily connected, so the water would take a little bit more time to flow through. And with clay, like, it might not even go through because those pore spaces are so poorly connected to each other. The water would just soak up and not go anywhere. We can see that there's great big differences in the permeability, the ability for water to flow through based on the grain sizes.
So it sounds like when we measure permeability, we're going to be measuring the volume of water or the distance it travels over time, right?
So some kind of a rate which water is flowing.
Okay, cool. Okay, so I think that's all we're doing on this video. Quick video on porosity and permeability. And go ahead and jump out, take your quiz, and we'll see you guys in class tomorrow. Bye.
See you guys.